Hey guys, so I'm going to do a couple demonstrations with just magnetic fields. Uh, Really simple ones. It won't take too long, hopefully. So what we're going to be looking at today is we're going to be looking at an electric field through a current carrying wire. So I've got a loop here, and I'm just going to hook up. Hopefully, I never tested the batteries here, and we're going to see how the magnetic field is around this straight wire here. Excuse me for a sec. There we go. And we're going to basically just test it with a compass and things like that. We're also going to look at a current carrying coil like this and just a straight wire as well. Now my camera isn't the best camera, as you guys know. So I have to put it on my holder here, and hopefully that'll work for us when we're doing. So the first thing we're going to do is we're going to just look at the effect of a current on the magnetic field around a current carrying wire. And that's what we're going to look at first. So I'm going to change my camera here from over here to my holder. Hopefully I can get this to close that up, and we'll turn it on my holder here. It's got autofocus on, so we'll see how that goes. And there's shooting down, so that should work for us. Okay, so if I take a compass out, a compass will detect our magnetic field. Let's adjust that. I don't know how I want to adjust this. Just hang on. And we're going to talk about something called the right-hand rule today for magnetic fields. Now, most books will teach what's called the left-hand rule in high school because they all say electron flow. They'll talk about electron flow. I teach the right-hand rule and current flow. Remember, the reason that I do that is because in actual electricity, the positive lead is considered the live lead, even though that it's. And the reason that happened is because when Ben Franklin did his investigation, he assumed that the positive charges moved. Okay, just going to pause for a second here, guys, because I got a quick email I got to answer, and then we'll keep going here. Okay, so what I'm going to do is I'm just going to use a battery here. And I'm going to connect it up, and then we're going to just do a straight wire here. This might get a little hot. I don't know. We'll see. I'm going to use this blue wire. I think it's thicker. Okay, so I'm going to put this on the negative lead here. Okay, and then I'm going to put this on the positive lead. So that means that when I hook it up, it's going to be flowing up on your screen here. So what I'm going to do is I'm going to hold this straight like this, and it'll be flowing that way. Okay, and then I'm going to put the compass on top to see how it deflects the magnetic field. Okay, so let's hook it up first. Okay, hopefully it doesn't get really hot because there's not much resistance. We will see. And hopefully it's actually live. Okay, so this is going between my hands here. It's flowing. Let's get this out of the way here. It's flowing this way. Okay, up on the screen. Okay, and I'm going to put this. Okay, you can see if I put this on here, it deflects it sideways. Okay, so if I take away the wire, okay, take away the wire. Okay, it's pointing, the red lead is pointing that way. If I'm going to put the wire right on top of it, watch, it'll deflect this. So I'm going to put this wire on top. Okay, and you'll notice that it's deflecting the compass. That's because there's a magnetic field around this current carrying wire. So take it away. Okay, put it on top. Okay, if it's going to deflect the opposite way if I put the compass on top of the wire. Okay, the red is pointing that way. And now if I put it on top here, red is pointing the other way. Oh, can't see because my hand's in the way. Okay, so this is detecting current in this wire. Okay, again. Okay, now if I just bring the compass close to this left side of the wire, notice it deflects it there. If I bring it on the other side, deflects it there. Sorry about my arm. Okay, you can try this if you got a battery and compasses in your school. Okay, and you can see that it's detecting a current. Okay, I'm going to remove this and let this cool off because the battery's getting warm. Okay, because I don't have much resistance on there, so there's nothing, it's disconnected now. So you can see that there is a current in the wire. So now the rule is if you point your thumb, if you take your right hand and you point your thumb in the direction of the current and you wrap your hands around it, okay, your fingers curl in the direction of the magnetic field. So you grab the wire with your right hand, pointing your thumb in the direction of the current, conventional current, okay? And your fingers curl around the wire in the direction of the magnetic field. So that means if I put the wire on top, the magnetic field is point on top of underneath the wire underneath where my hand is there. It's pointing this way where my fingers are. If I curl it around, it's pointing straight up towards the camera on the far side of the wire. And then if I keep curling it on the very top of the wire, it's pointing this way to the left of the screen, okay? And so forth. So that's what the right-hand rule for a current-carrying wire is. Okay, so let's also try that with this here setup here. Okay, here we got just a little live thing. Okay, this is just a square loop of some really low resistance wire here. Okay, and I'm going to put my calculator there. Okay, I lost a leg on it. That's okay. Let's get it centered here. Okay, so right here is the wire. Okay, and coming from the red, going up, across, down to the buck. Okay, so we're going to look at the magnetic field across here. So what I'm going to do is take this battery, and I'm going to hook up the current. So I'm going to hook up the negative lead of the current to the red. One. Okay, and there's no circuit yet. Okay, so if we put this on top, put my thing on top here. Okay. Okay, so that arrow is pointing right along the wire. Okay. Okay, now when I hook up I'm going to do that. Just hang on, I got to get the other wire ready to hook up here before I hold that there for you. So I'm going to hook up positive lead here, so that the current will be flowing in this direction right here. Okay, I've got the wire pointing in the direction of the current. So that wire, or this arrow on the compass, is pointing in the direction of the current when I plug it in. So I haven't plugged it in yet, so I'm going to plug it in and watch what happens. Ooh, that's hot. Hang on. I got to get my glove here. A little bit hot. There's not much resistance in this one. Okay, so let me just touch it. I can't hold it on for a long time because these wires have very little resistance, and I didn't bring my resistor with me. So it's deflecting it completely around. Okay, so that red dial is pointing to the west area on the compass right now. And you'll notice when I plug it in, right there, it deflects to point to the east. So that means the magnetic field is going towards the east. Okay, now if I reverse the current, so I'm going to switch the current around, it shouldn't deflect at all. So now the current is going to go the opposite direction. I'm changing the positive and the negative. So it's going to go up. It's going to go the opposite direction of this arrow. So it's going to be flowing this way now. So let me touch. And you'll see that it's pointing, it doesn't deflect. It still points west. Okay, it's pointing west. So according to the right-hand rule, this is on top. So according to the right-hand rule, if I grab it, point my thumb in the direction of the current, and I was on top, the magnetic field should have been pointing to the west, and it was. Okay. So now if I take this and I put it underneath, so that according to the right-hand rule, my fingers will be underneath there. So this should cause, if we have the flow going in the opposite direction of the arrow on the compass, so it's going to go, instead of up to the top of the screen, it's going down. It should deflect to the east. And it does. Okay, if I take away the power, it goes back to its normal position. Okay, this is underneath the wire. The wire is on top of the compass, pointing to the east. Okay, and the current is flowing opposite direction of the arrow in this case. Okay, so if I reverse I'm going to reverse it and go back to the current flowing in the direction of the arrow so that it's easier for us to see. So now current is going to flow in the direction of the arrow, up towards the top of the screen. So there should be no deflection here. And I've got it plugged in right now, and there's no deflection. Okay, now if I put the compass to the right here, okay, according to this right-hand rule, the magnetic field will be going up. Let's see if it does any deflection to the right. Okay, the current is going in the direction of the arrow on the compass. Slight deflection. Ooh, that's hot. Slight deflection. Okay, you can see that there is a magnetic field there, but it doesn't displace it. If I put this on the other side of the wire, okay, so this would mean that the magnetic field is going down. Okay, slight deflection, but nothing much happens. But if I put it on top of the wire, deflects it right around. Okay, so that's the magnetic field about a current carrying wire. Okay, the other demonstration that we want to do is we want to go in a coil as well. Okay, so I'm going to remove this setup here. Okay, now a coil has a right-hand rule as well. I'm just going to pause for a second here, as you probably heard my email go there, and I will pause and I'll be right back with you. Okay, sorry about that. So I'm going to look at a solenoid or a coil of wire like this. Okay, so the right-hand rule for this, okay, so this is just circles. If you look down at like this is just circles like that. Okay, so the rule is this is in loops. Okay, so that means the right hand rule for a solenoid or a coil like this: if you grab the coil with your right hand and curl the fingers around in the direction of the current. So I grab it and I curl my fingers in the way that it's flowing through the wire. My thumb is going to point to the North Pole. Okay, so let's kind of take a look what happens with the compass on this one. And the magnetic field is really, really strong with inside this. I don't think I'm going to be able to get the compass inside this coil here. I'm going to have to go get a smaller compass. Just give me a second here. I'm going to pause again. I'm going to run and go grab a smaller compass. Okay, so I picked up this smaller compass here. Hopefully it'll fit in there. And you can see that it's pointing. Okay. Okay, you can either look at this here one or this one. We'll go with this one here. Okay, pointing down towards the bottom of the screen. Or, well, I guess not the bottom of the screen. Camera's all sideways and stuff. So what I'm going to do here, first of all, is I'm going to put this compass inside the solenoid. Get it in the middle. Okay, and now according to this, this is going to come and the current is going to flow. The way I'm going to hook it up, the current is going to flow down. Okay, it's going to go this way. It's going to come, or whoops, I'm wrong. Pardon me. It's going to go this way. It's going to go flowing where my finger's pointing, around the top and then around the bottom. And so it's going to be, so if I'm grabbing it with my fingers, curling it around, the thumb is going to be pointing there. Okay, so I'm going to plug it in. Okay, so let me loosen this one here and we'll plug this baby in and see what happens to the lead of the compass. Okay, right now it's perpendicular to the coil while it's parallel to the coil lines, coil loops. Okay, so this is going to be here. Which is negative. Okay, this is the negative one here. So the current's going to come in from the black knob. There. Okay, so let's go ahead and plug this one in first, and I'm just going to touch it because it gets hot and I don't want to melt the battery. Okay, nothing so far, nothing. I'm not, okay, no power going through, no power going through yet. Okay, I'm going to touch it and we'll observe what happens. Oops. Okay. Just hang on. Okay, there we go. It's hooked up. Nothing. Nothing at all. Maybe this thing isn't connected here. Let me check the bottom here. Oh, that could be the reason there. Or maybe my battery died out on me. Okay, let me just change the leads here. Okay, let's try it. We're going to touch it again, see if it, there we go. Okay, so it didn't deflect last time. So this time it's deflecting. I had it hooked up wrong. So you can see that it's now, the direction of current flow, that's magnetized, so it's freaking out the compass. Okay, so I'm going to flow the current from the red knob to the black knob. Okay, and it deflects it. Very, very strong magnetic field in there. Okay, and then I disconnect it, it goes back to normal. Now, if I reverse it, you'll notice that it didn't do anything. Maybe I didn't have it hooked up. Now I'm going to reverse it, and hopefully it'll go the other way. We'll see. It was probably just that I didn't have it hooked up, but we'll see. Yes, I had it hooked up incorrect. Now I'm going from the black knob to the red knob, and you notice it's pointing the opposite direction. Okay, the shiny part of the compass is pointing north right now, or the more darker colored knob of the compass is pointing to the south. Okay, take that away. Reverse the current now to go from red to black. Ooh, that's warm. Let me just cool off the, ooh, that's hot. There's not much resistance here, so okay, that's cooled off enough, I can move it. So now I'm gonna go from the red knob to the black knob. So it should have it pointing up. You know, the darker one now is pointing to the north. It is kind of oscillating, but I'm not holding it there long because it gets really hot. Now look at that. It's like, what's going on? It's a very sensitive compass. Okay, and it's not plugged in now, I'm just letting it settle. Okay, and then I'm going to go from the red to the black again. Okay, there you have the North Pole pointing to the black. Okay, we can't keep it plugged in too long. Okay, another thing we can try here is, what if we take this compass and put it not on the inside, just on top, like that. Okay, so I'm going to have it go from the black lead down to the red lead. Or sorry, that's incorrect. It's going from the red lead to the black lead. Didn't change anything. Notice it's deflecting the other way because it's on the outside now. Okay. Let's see if we can get a magnetic field. Okay, we've got nothing's plugged in now. Got a metal bar here, iron bar. Doesn't show anything. See if we can induce a magnetic field on this by putting it in here. Okay, we'll put this on this one. Okay, and we'll see that if the compass deflects there. Oh, there's lights are kind of tough to see the compass there. Stupid lights. Okay, now I'm going to induce a magnetic field by plugging it in. Okay, here we go. On it goes. So you can see that it deflects to this pole here, being north. So the south, not perfectly, but it deflects it. Okay, so that's the coil. So there's a little demonstration of wherever you have a current flowing, whether you have through loops or through wires, you have basically you have a magnetic field being produced around these wires. Okay, so that's a little demo there. I'm going to put the camera back now. Okay, and that was about 20 minutes or so. Okay, so let's put the camera back where it was. It's not the greatest one, but at least it worked okay. Okay, so that was about we got about 23 minutes, 24 minutes, 25 minutes going to be when I'm finished talking here. Video on just how the current was changing. Now we'll do a little bit of a summary here in the second part of today. I'll just summarize some diagrams of the coils and things like that in some notes that we're going to do, and it might take me 2 periods, but I'm going to do about a 20-minute one. So I'm going to stop the video here and then do a little bit of diagram about current around a wire, and then around a coil. Okay, so that's what we'll do.